Day 10, I think. Yep. No. Yes. No. Yeah. Day 10. Do I need a calculator? Hopefully not. Let's get this started. So number 1, a meteorologist was monitoring temperature outside in degrees Fahrenheit and wrote the expression 78 plus -6 minus 5. Which statement best describes the expression? So the temperature started at 78, correct. So with 78. So plus -6, so it went down. So this one says increased by 6 Fahrenheit. No, it didn't increase. It went down. Because if you do 78 plus -6, you get 72, right? So the temperature definitely went down. So anything that says increased, I'm going to already throw away. So the temperature decreased by -6, and then what happened there? So 78 plus -6 is 72, and if you do -5 again, guess what happens to your temperature? It drops again. So decreased, check, and then the temperature decreased by another 5. So correct answer is C. So this one says decrease and increase. It makes no sense. Which expression is equivalent to 2.2 minus 2.5? If you actually do 2.2 and change it to an addition, make it minus 2.5, right? You actually get negative 0.3. Right, you get a negative number. There's more negatives. So 2.5 minus this is not, because subtraction is not commutative. So A is gone. B, 2.2 plus 2.5 is not the same thing as 2.2 minus 2.5, so that's garbage. 2.2 plus -2.5, ding, we have a winner. Look what I had written before, right? So if you change the subtraction problem to an addition problem, the first add-in stays. We change the subtraction to addition, and then we change 2.5 here to its opposite. We added it in the inverse, which is -2.5. So the answer is C. So far, so good. 3, indicate whether each expression at table is equivalent to half x minus 1, equivalent to x minus 1/2, or not equivalent to either of those. So let's do this one. So you actually have to do this 3 problem. So let me take 2/3, 3/4x minus 3/2. So if I do this, right, I'm multiplying those two first. So if I actually multiply those two first, let me actually do this over here. 2/3 times 3/4x, right, and then I'm going to do, so if I multiply, and then minus, right, because I have to do this, guys, 2/3 times 3.5, times over here, let me put a button over there, right? So positive times a negative is a negative, there's my big negative, and 2/3 times 2. So let's see what we get. So here, cross, cross, simplify again. So all this becomes 1/2 of x. Minus this becomes 1 and 1, 2 and 2 simplify to 1 and 1 again, 2 minus 1. So the first expression is half of x minus 1. So check. Is that equivalent? Is that the same thing as this? No, it's not. And we're good. Right? So this whole thing becomes half of x minus 1. The second part, so we know this one is already this one. So again, let's remove the parentheses. So pretend there's a little 1 over here. 1 times 2x is 2x. 1 times +1 is just 1. And then again, there's a little 1 over here. So my -1 minus x is minus x. -1 times a positive is a negative, and 1 times 3/2 is just this. So actually, I'm going to just change that to a decimal, and I can always change it back. So combine like terms. Yes, I have this and this I can combine. 2x minus x. Remember, there's a 1. What's 2x minus 1x? It's just x. And then I can combine this guy with this guy. What's +1 minus, so +1 minus 1.5. We can think of it as 1 plus -1.5. There are more negatives. Minus 0.5. And I'm just going to rewrite this as a fraction because it's x minus 0.5 as a fraction is a half. So this guy over here is not equivalent to this, but it's equivalent to the middle one. Okay. 4, Jordan's dog weighed p pounds. Emmett's dog weighs 25% more than Jordan's dog. Which expression represents the weight in pounds of Emmett's dog? So if Jordan weighs this many, Emmett's dog is going to weigh whatever this guy weighs times 1.25, right? Remember, 100%, 25% more means the 100% plus the 25% over here, right? So, and that, so 125% is expressed this way, right? As a decimal, we move the decimal 1, 2 over, so it would be P times 1.25. So to find the weight of, what do you call it? Of Emmett's dog, you would do that. So and again, you know what? I'm going to actually change this. And I'm going to change it with numbers. So Jordan's dog weighs 100 pounds. Emmett's dog weighs 25% more than Jordan's dog, right? So how can I find the answer? So if here's Jordan's dogs, who weigh 100 pounds. So actually 100 is a bad example. Let me choose 50. There you go. Jordan's dog weighs 50 pounds, right? So if I want to find out how much Emmett's dog, and Emmett's dog weighs 25% more, so which means that Emmett's dog weighs 50 pounds as well, plus 25% more, right? So if you think about that, right? So think about P, the way that, so wherever this is, you write P, 0.25 times P is going to be what? 12 and a half, so that doesn't make sense. 125 times 50, that makes sense because it's going to be 50 times 100%, which is 1, plus the 25%. The correct answer is this one. Okay. So again, I guess what I'm trying to tell you is if you have something like that, change that P to a number. Okay. An easy number, 50 would have been an easy number, and figure out which of these expressions over here would actually help you to find the answer. Okay, so think about it. If the dog weighs 50 pounds, and let's change it to 50. Let me change all that to 50. This is how much Jordan dogs weigh. So 50 pounds plus 0.25, 50.25. Does that mean Emmett's dog weighs 50.25? That doesn't make sense. That's not 25%. Right? How about 50 plus 1.25? That would be 51.25. That also doesn't make sense. The last one is actually works because it's 50 plus 25% of that. So if you took 50 times 0.25, right? Find out what that is and then add it to 50, that would work. So actually, I'm sorry. We have two answers here. This one and this one. Okay, remember this is the more direct way and this one is the one that takes 2 steps. 6. Here is something, I have no idea what we're talking about. The graph shows the amount of protein in peanut butter. Which statements describe the meaning of the 0.630? 0.630 is this one. So you need 6 tablespoons and you get 13 grams of what do you call it? So 6 tablespoons. Gets you 30 grams of what? Protein. 30 grams of protein. So that's what it's saying, protein. And all right, so let's look at the statements. There are 6 grams of protein per tablespoon. So again, let me just write so that let me write like this: 6 tablespoons of peanut butter gets me 30 grams of protein, and I get the information from grams of protein. So I got this information from the graph. So let's see. Now, this is saying that 6 grams of protein per tablespoon of peanut butter. So I can simplify if I divide this by 6, 1 tablespoon. That gives me 5 grams of protein. 5 by 6, right? Yeah, 5 grams of protein. 30 divided by 6 is 5. So this is not true. There are 30 grams of protein per tablespoon of peanut butter. No, it's 5 grams of protein for 1 tablespoon of peanut butter. So that's not true. There are 6 grams of protein in 30 grams of peanut butter. No, there's no 6 grams. There's 30 grams of protein in 6 tablespoons. And there are 30 grams of protein in 6 tablespoons of peanut butter, which is what I originally have here, right? 30 grams of protein in 6 tablespoons. So the answer is D. The amount Troy charges to mow a lawn is proportional to the time taken to mow the lawn. Okay, so if Troy charges $30, so let me just write $30 to mow a lawn that took him 1.5 hours to mow. So let me write that like this: $30 to mow lawn. So it's $30 over, let me just write this again. 30 over what? Over 1.5 hours, right? 1.5 hours. So that's your ratio here. So we're looking which equations models the amount in dollars D that Troy charges to mow to the church when it takes him H hours to mow a lawn. Okay, so trying to figure this out. So so the total D is, and then we can simplify, find the unit rate here, right? Divide this by 1.5 and divide this by 1.5. And 1.5 of 30 divided by 1.5, hang on a second. It's going to be 20. Right, so 30 divided by 1.5. So if you divide both top and bottom by 1.5, we get the unit rate. So the unit rate here is $20 in 1 hour. So that's his unit rate. So the total D, in order to find, and it says the total amount D, to find out how much he's going to charge, all you have to do is multiply $20 times the number of hours, in this case, H. So is there any expression that looks like this? Yeah, there is. A. Right, so if you work 4 hours, it's times 20. If you work 5 hours, it's times 20. So his unit rate is 20 per hour. 7, on Monday, the temperature at 10 a.m. at Sam was -6. So again, if you use this, so here's 0, so it's a -6. The temperature at 2 p.m. at Sam's house was 2 Fahrenheit. So what happened here? The temperature went up, obviously. So what happened from 10 a.m. to 2 p.m.? The temperature increased, I'm going to circle this, by how much? So from -6 to go all the way to 2, -5, -4, -3, -2, -1, 0, 1, 2. So think about 1, 2, 3, 4, 5, 6, 7, 8. It went increased by 8 Fahrenheit. Number 8, determine which expression is equivalent to this. So let's simplify that. So I get 3/4, and I'm going to apply the distributive property here, and apply the distributive property. So x times a half, it's going to be, for negative and the positive, it's going to be, first of all, 1/2 x. Remember, the coefficient comes first. Negative times a negative is a positive. And then x times -5/8 is 5/8x. And then plus, well, here we have a plus and a minus, right? Let me put a 1 there. What's a positive times a negative? It's a negative. And then 1 times 3/8x is going to be -3/8x. Can I combine like terms? Yes, I can combine these 3 guys over here. So the 3/4 is going to just hang out there, right? So, and then minus x, and so I'm going to combine half of x with plus 5/8x and minus 3x. Already, I can tell you that you can throw this guy in the garbage, because I know my answer is going to have 2 terms, one with a variable, one without a variable. So this one's also garbage. And the one without a variable is 3/4. Is 3/4 the same thing as 1/8? No. But the only one that's similar to this is this. So in your calculator, you can just do -1/2 plus 5/8 minus 3/8, right? And you should get -1/4, right? So that's our answer here. And again, use process of elimination here. This one is, you can think like that too. Ruben put an empty cup under a leaking faucet. After 1.5 hours, he collected 1/4 cup of water at this rate in cups per hour. What is the rate in cups per hour? So I know that it's 1/4 cup in how much? In 1.5 hours. 1.5 hours. So I'm going to change the 1.5. Right? So just over here, I'm going to write 1 and 1/2. It's the same thing. 2 times 1 is 2. Plus 1 is 3. So it's 3 over 2. I'm just going to write 3 over 2. Right? So I want the unit rate. I want to change this to 1 hour. So how much water is leaking here? So 3 over 2, I'm going to multiply this by the reciprocal, which is 2/3, right? So 3 over 2 times 2/3 is 1, because remember, this all simplifies to 1. So on top, I multiply by 2/3. 1 times 2. And again, we can simplify. 2 divided by 2 is 1. 4 divided by 2 is 2. Now I can multiply. 1 and 1 is 1. 2 times 3 is 6. So in 1 hour, how much is it leaking? 1/6 of a cup. So that the answer is A. 11. Ali's collecting signatures for petition. He has currently 520 signatures. He has 6 more weeks to collect the remaining signature he needs. He needs a total of at least 1,000. He wants to collect the same number of signatures each week. Which line represents all possible numbers of signatures? So we're looking at an inequality here, right? So let me write what we know. So whatever I need, he needs to collect at least 1,000 signatures. So he needs 1,000 signatures, right? Or more. So how many does he have right now? He already has 520. Plus, he's going to go around for 6 weeks, and every week he's going to collect, I don't know, an equal number of, what do you call, signatures, right? So, but he doesn't have to collect 1,000 because he already has 520. So let's solve this, right? So again, one thing you should know right away, well, this is going to, well, let's just do it. Minus 520, minus 520, right? Here's my line in the middle. This crosses out, 6x comes down, is greater or equal to 1,000 minus 520 is 480. Divide this by 6, divide this by 6. X is greater or equal, and 480 divided by 6 is 80. So now, if you were to look at this, right, we want numbers that are greater or equal to 80, and that is A. Look at your number line. It's shaded. Here the dot is shaded, and it's pointing that way. So that's the correct answer. $11. The salesperson earns commission on the sales that she makes each month. So salesperson is 5% commission on the first 5,000, and she earns 7.5% commission on the amount of her sales that are greater than 5,000. So this month she had 8,000 in sales. So 8,000. So her commission. So the first $5,000 that she makes. So she made $5,000 first. So over here, her interest rate is going to be 5%. And then the 3,000 after, right, 5,000, everything after 5,000, she's going to earn 7.5% commission. So if this lady sold 8,000, how much would she get paid? Well, let's find the commission here. So remember, the commission is the sales, right, the percent times the sales. So she got 0.05 times 5,000. If you multiply that, 0.05 times 5,000 equals, so she's going to get commission of $250. And then after 5,000, anything she sells more than 5,000, she gets a little bit more commission, right? She gets 0.075 times 3,000. So 0.075 times 3,000 equals 225. So how much is she making total? 250 plus 225 is 475. So that's how much she's going to make. Okay, it's a nice plan. So part B says, a salesperson earned Again, under 5,000, she gets paid how much? 5%? Was it 5%? No, it's 5%. So part B says she made 1,375 in commission last month. How much money in dollars did she have in sales last month? So, how would I do this? Hang on a second. If I calculate it at 5%, no. Hang on a second. So I know, oh, I see. So I can use the answer. So I can use the answer. I know that $5,000, she's going to make 250 in commission, right? So 5,000 in sales, commission is 250, and this is at 0.05, right? So I need to find out. So the commission is 250. So if you subtract 1,375 minus 250, it means that she made $1,125 in commission at 0.075 and this sales. And that's what we have to find out, because remember, the first 5,000 she only makes 5%, right? So she made the bulk of it on sales after $5,000. So let's find that out. So the commission equals sales times the interest rate, and in this case the commission was 1,225, 125 times the sales, which I don't know, so I'll call it X, times 0.075. Divide both sides by 0.075. So X equals, divided by 0.075, X equals 15,000. So apart from her initial 5,000, which she got 250, she then sold $15,000 worth of items to get 1,125. And then together, these two commissions at these two different interest rates earns this amount. Good question. 13, 12, 13, so let me make it smaller. We want, here's a box plots. The sample from each school is 30% of the student population, okay, so it's not the whole population. Which comparison is true? Grade 7 students are typically shorter. In grade 7 students, okay, grade 7 students from grade 8 are typically shorter than grade B because the difference in the interquartile range students, because of the ranges. So, students in school A are shorter than students in school B. The interquartile range, the IQR here is 61 minus about 50, so about 5.5, and the IQR here 62 is about 60. IQR is about the same. Does that mean 50% of the students are that height? What question is this? In a second. Number 12. ちょっと待ってください. Pause. Alright, so I don't know if it's 12. Let's see. Grade 7 students from school A are typically shorter because of the difference in the medians. Okay, that I would say, right? So the median here of school A is definitely shorter than school B. So I wouldn't be opposed to that. I'm thinking that, so that looks like okay. Grade 7 are typically taller? No. And grade students for grade school A are typically taller than grade because of no. The only one that makes sense is, which one was it? Students from are typically taller? No. This one, B. Right? I guess we just have to read it all. This doesn't look like the sheet we were doing, is it? 13. The spinner is divided into 8 equal sides. Each section is labeled with a number. Jake spins the arrow on the spinner. Write the events in the correct order from least to greatest. So I'm just going to write here. So there's 8 sides, and the probability of getting a 1 is 4 out of 8. Probability of getting a 2 is 1 out of 8. And probability of getting a 3 is 2 out of 8. And the probability of getting a 4 is 1 out of 8. So just for me to have it on record. So arrow lands on a section labeled with an odd number. Oh, boy, odd number. Odd number. Probability of odd is 1, 2, 3, 4, 5, 6. 6 out of 8. So ignore all this stuff I did for no reason. Probability of 1 is 1, 2, 3, 4 out of 8. And the probability on a section labeled with a number less than 4. Less than 4 would be 1, 2, 3, 4, 5, 6, 7. Less than 4. 7 out of 8. So that's in order. Obviously, this would be least. Likely. And more likely. All right, so let's just go down here. So I would definitely write in order. It would be, the least likely would be B, right? So this is the least likely. And then more likely than that would be 6 out of 8, which is odd number, which is A. And the last one, obviously, C. So BAC would be my choice. Okay. And that's that for whatever day this was, 10.